Hey folks, Chuck Black here. We're doing 52 weeks of Python. We're in week number 36 and our topic is object-oriented programming. In fact, we started last lesson talking about it with pictures and theory and stuff like that. We talked about how object-oriented stuff means creating these things called objects, and each object has its own data and its own code, and so this kind of reflects the real world a little bit better. It allows us to hide details from somebody who wants to consume or use our objects. It also allows us to do things like inheritance, polymorphism, and things of that nature. So this particular lesson, we're going to look at some code that actually implements it in Python, implements this object-oriented stuff. Now, there's different ways to do it. We're doing a more simple version like you see down here, where you create a device and it has a bunch of data to represent the host name. It has a bunch of methods like connect, get fax, disconnect, etc. And so that's what we will be talking about. The output, we will be talking to the same device in three different ways, once using netmiko, once using Napalm, once using ncclient. It's going to be something similar to this, but we're not using inheritance this time. So what we're using is we are having a single class of device, and we are indicating what type of connectivity we should have with it or what transport we're using. And so we're dipping our toes into the world of object-oriented programming in this lesson, and that's what we'll be talking about. So hopefully I'll do a halfway decent job of describing things, and you'll come away with this with a better understanding of how to actually write object-oriented code using Python. So let's get started. So before we dig into the code, which we're going to do, let's remind ourselves something about the theory of object-oriented programming that we talked about in the last lesson. So we talked about how in a traditional way of doing things, we had data that we created, and then we had code that we created, and the code, all of the code, could manipulate all of the data in general. And the way that object-oriented world works is you have objects that you create, and every object that you create has its own data and its own code that operates on that data. And so you can have a number of these things of different types and capabilities, and that's what we're moving towards. Why do we want to do this? Well, object-oriented does reflect the world a little bit better than just this thing over here. You can get this traditional stuff to do what you want it to do, but it's less of a genuine reflection of the way that the world is. For an example, in the example that we're going to use, networking devices, we can think of them as objects that have their own data, and then they have functions or capabilities or code that would operate on those. Encapsulation, well, we talked about how it's good to hide the details, and so we will be hiding a lot of the uglier details of particular types of objects inside the object itself in the code that we create, and therefore the person using them, consuming these objects that we create, doesn't have to know about those. And when we get beyond this particular piece of code, we will talk a little bit more about inheritance and polymorphism. That will either be the second part of today's lesson, or it will be another lesson on its own, because I have two different sets of code that we can look at to do that. So that is the general overview. We did talk about how what you end up doing is you create a definition of your object type, which we call a class. So you create you define a class that has data and it has code in it, and then you create instances of it, and those are the actual object instances that are reflected here in this picture. And so that's what we're talking about, and keep that in mind as we begin to dive down into this code. Okay, one more thing before we dive into the code. I created this picture so that you would understand exactly what it is that I'm doing. So I'm not just waving my hands, and I want to compare it to what I will be doing next when I do the second implementation that I mentioned. This first implementation, I'm going to create a device object, and this device object is going to have a lot of the usual suspects that you would assume if I was going to be creating a device object that represented a real device out there in the world. I mentioned that I'm going to create this device thing that is going to be able to communicate using netmiko or Napalm or ncclient. So if you want to think about how this might be in a real world situation, I'm not saying this is how it really is, but if there was a situation where certain devices needed to be communicated with raw SSH, certain devices I could make use of the nice Napalm abstraction, and other devices I needed to do raw netconf. If that was true and I wanted to not have to have my user of this functionality have to do all of the ugliness of determining which of these to use and how to use them, if I wanted to hide that, in other words, encapsulate all the differences inside my object so that the user dealt with something more abstract, then I could create an object such as this. And this is going to be some of the data that I will do. If I look at what methods do I want to provide, I want to provide a connect method so that somebody can just call from my object and say connect, and it will go out and do all of the dirty work of connecting to the device, whether that's done via netmiko or Napalm or ncclient. Something else I might want to do is do a get fax. Now with Napalm, there's actually a method that I can call to get my fax, but I'm going to have to manufacture that for netmiko and ncclient, and you'll see I've done partial implementations of these just to give you the idea. One thing that they all would have in common, but you would get in a different way, would be to get the running config. So I actually haven't implemented this at this point in time, but it's pretty trivial to get the configuration using netmiko or Napalm. ncclient, it's also trivial to get it, but it does return it to me in this unhelpful XML format, which I can actually fairly easily translate into Python, but these things that I get from netmiko and Napalm, those aren't in any nice format. They're just a big honkin' string with a bunch of new lines in it. So anyway, so I haven't implemented that, but I have implemented disconnect. So that is what I'm going to do. I want to give you a sneak peek. If I was to do this a different way, then you might use inheritance in order to do that. Now, just make sure you're listening to me for this when I say this. This first implementation that we're going to look at right now is not using inheritance. I have another implementation of this that uses inheritance, but I wanted to keep it simple, and we could argue about the definition of simple, but I wanted to keep it simple by not using inheritance in the first pass of this, so you could see how to do that. This ends up being a little bit less object-oriented-y, even though I'm implementing an object, and a little bit more traditional code like you're used to. This will make use of more of the object-oriented functionality. But like I say, the code that we're going to look at first is going to be code that implements the stuff that looks like this. So now for reals, let's look at the code. Okay, so let's actually look at the code now. So I'm starting from the top. That is, I'm starting from an application that is actually using this device class that we have defined. So I'm going to look at our usage of it first at a high level, and then we're going to dig down into the actual definition and see how that actually works. How do I, as a user, a consumer, or somebody who benefits from this device class, what does my code look like? Well, the first thing that we do is we create devices. So this is the code right here where I'm actually creating the device objects. So I'm going to go through that in just a minute, but not right now, because I want to focus on the code that actually does something. We would call this in a real live application, this is like the logic or the business logic of the code. What is it that I'm going to be doing? So let's look at this statement here. This is just a for loop, but this may give you pause. I don't know that I've described an underscore other than its existence in the middle of names to separate words, etc. But let's take a look at this and just try to figure out what this statement is. It's a for loop. What is it looping through? Well, Devices obviously isn't a list because I don't need to say .items. If it's a list, I say .items and call that function if it is a dictionary. And you'll remember if I'm going to iterate through a dictionary, it's going to look something like that. And the variables that I get for every iteration, I get two of them. The first one is the key, and the second one is the actual value from that dictionary item. And what this underscore is saying is I don't care about this particular value. In this case, it's the key. I don't care about the key. I'm not going to use the key. So I just do underscore, and it goes ahead and does the iteration through the loop. I do care about device, and I will be using that. You will see for loops with underscores, and that's what that means. It means I don't care about this particular actual value. And so that's just to be aware of. That's what that is all about. So I'm going to iterate through all of the devices that I have created. So I'm going to create 3 devices just at a high level. One is going to be a netmiko device, one is going to be a Napalm device, and one is going to be an ncclient device. And what am I going to do? Well, I'm going to connect to the device. How do I connect to the device? Well, this is my device object, and I have defined in my device object a number of methods. Remember, a method is just a function that's defined within a class. I've defined a connect method, I've defined a getFacts method, and I have defined a disconnect method. And so I can go through this loop, and I don't care if device is doing its dirty work using netmiko or Napalm or ncclient or something else. All I know is, and all I care about is the first thing I'm going to do is I'm going to connect to that device. And if that's successful, then I'm going to do getFacts. Now, as you can imagine, getting the facts is going to be different if it's netmiko versus if it's Napalm versus if it's ncclient. And so I, however, as a writer of devices app, didn't have to care about all of the nitty-gritty details of how that actually is done. So quite often on software teams, you will have one person who implements the device, let's say, in this example, and another person who uses and consumes the methods and the data that is provided by that device. This person here doesn't need to even know all the details about how the facts are gotten. It just cares about the reality that it gets the facts back when it calls this function. And I print them out, and then I do a disconnect. And if I look over here at the code, each one of these is for a specific device. And you'll see that my facts are much richer for Napalm, where they've spent, weeks and months, etc., however long it's been around, creating the functionality to get facts. I just did it over the weekend, so I only did a few things, but I did get the host name and the operating system version and the serial number and the uptime using netmiko. So I did that, and this is what I printed out. Now the second device was actually a Napalm device, and so my Napalm device, as you can see here, all I had to do is call getFacts, and it returns these things. The interface list is something that I didn't do in mine. You can see this is a sandbox thing because everybody's creating a billion different interfaces. It has the model name, it has the OS version, which I have, serial number, which I have, and uptime, which I have. And vendor, I'm not sure where Napalm gets that, and then I disconnect. Now the last thing that I do is I connect to ncclient, and so I'm doing ncclient to connect to the device. And because I'm short of time and I'm not really interested in creating an entire XML replication of getFacts, I got one item, which is the serial number. And you can see here the serial number, it is the same exact device, but you would expect the serial number to be the same. That was actually, trying to think, getting the serial number was fairly easy with ncclient. It required regular expressions up here with netmiko. So that is what the code actually does. So the point that I want to reiterate here at this topmost level is I did not have to worry about any of the details of connecting, of getting the facts, or of disconnecting, because that was all taken care of me. That's part of the idea of this encapsulation thing that we talked about as an advantage. It encapsulates all of the details and I don't have to worry about it. Okay, so that is the high level detail of what my application does. Next, let's look at creating these actual objects and how that happens. Okay, so the next question is, how do we create an object? Now, if you recall from our slide, if I go to this slide here, you know that there is a class definition and then there's an object instantiation. Here I say capital D for device, and then I pass in a bunch of parameters, and bingo, my device gets created and I have an actual object that has been created based on the class definition. That's what we will be doing, and it's the same here. I've made a few changes since I made that slide, but this is the important stuff that I want you to look at. This is for netmiko, it's the same for Napalm, and it's the same for ncclient. These are my three instances of what I do. So let's look just at this one up here. Now, created devices, we realized was a dictionary, so I'm saying that it's a dictionary. Now let's look at what I'm going to do. So I'm going to say for my dictionary, this is just pure Python right here. There's nothing object-oriented about this at all. This is a dictionary. What do we call this thing in the quotes? This is the key for my dictionary, and the value is going to be this thing right here. Now, my black formatter that I run has decided that this is too long a line. It could have been on one line, so it separated it. So basically what I've highlighted here is the same thing as what we were just looking at here, except that I'm specifying the actual keywords for each of these things, and it's split across multiple lines. And of course, so those two are the same. So I'm passing in to my creation of this device type of object, I'm passing in a number of parameters. Now, the way that this works is as follows, and I'm going to give you a sneak peek. When you create something, what happens is, and this is an important word, its constructor is called. So be aware and remember that word. In Python, the way that we define the constructor is with this underscore, underscore, init, underscore, underscore. And this defines the parameters that are going to be passed when a device, this device class, when it becomes an object instance. In other words, when it is constructed. That's why it's called a constructor. And what are we going to do? We're going to save a bunch of this stuff. Now, I'm going to come back to here later, but I just wanted you to be aware that's what's happening when we say device parentheses, and then we pass in these four parameters. Basically, this is going to create an object instance of class device, and it's going to create them with these parameters. We're basically passing in these parameters to the init function, and it's going to get initialized. And when this completes, when this is done, I have created a brand new device object, and that's going to be the value that is associated with NXOS netmiko. And you'll notice that I put the transport type equals netmiko here. That's an important thing. Now, now I have my device object. It's called create devices. It's at this location, this with the key of NXOS netmiko. The next thing I want to do for this thing that I've just created is I want to set the port appropriately. So I know that I'm going to be using port 8181 for my netmiko call. So I set the port, and then I need to set the credentials. So here I set the credentials to the username and the admin. So once I am done with these lines of code, I have one item in my create devices dictionary. Its key is this. And what is the actual data? What's the value? It's an object, and it's an object that I created there. I modified it when I called set port. I modified it again when I did set credentials. Let's look in here just so that you're not confused. Here's set port. What does it do? Amazingly, it sets the port. Set credentials. What does it do? It sets the username and password. That's all that they do. Pretty simple and straightforward in that regard. Now I'm going to do this thing for all 3 of these different devices that I am creating. Now, if you're reading from a YAML file, if you're discovering devices and you learned about whether we needed to use ncclient or Napalm or whatever, and you got things like host name, then yeah, maybe you wouldn't have to do this manually. But because I just have 3 different characterizations of this same device, you notice the host name is the same in all of these situations. I am simulating having different devices that require communication in different ways. In actuality, if I was just communicating with it, I'd probably use Napalm, but here it's showing that I can do SSH and ncclient as well. And then I return created devices. At this point, we have a dictionary with 3 items. What are the items? The items are actually devices, these device objects, and that allows me to iterate through them. And I'm using device, which came from my devices. Here I do devices gets set to what gets returned from my function. So this device here I'm going to call connect and get fax and disconnect. And just as a sneak ahead look, you would expect there to be a connect. Sure enough, there's a connect. You'd expect there to be a get fax. Yep. And disconnect. So that is kind of what it's totally what we're doing in this function. And this is how we create our objects in this situation. First, we create them, and then I go and I call set port and set credentials. Now, you may ask, wouldn't it have been easier if I had just created my device object so that it took in port as well as username and password? And my answer to that is, yep, maybe it would be, but I decided to do this to demonstrate the creation of devices using a constructor and then calling into these methods to further set the details of it, just to show that we can call these functions. Okay, let's start to look at the device itself. Okay, so let's look at the device code, but before we do that, I want to remind all of us what I am implementing and what I will be implementing later in the next lesson. I am implementing this device object that you see right here. There's one device object, and in it, there will be all the normal information plus an indication of what is the transport, whether it's netmiko, Napalm, or ncclient. That's going to be important. And I have these functions that are going to be common across all different types of transports: connect, get fax. I didn't do get config at this point in time, and disconnect. I'm not doing this inheritance version, and the reason that I'm doing that is for teaching purposes, to keep it as simple as possible first, and then we'll tackle inheritance because that will take a little bit more time to explain. So we're doing this. So let's look at my device code. Here is my device.py class, and you can see that I'm going to be connecting via netmiko, Napalm, ncclient, all within this device, or at least I'm going to be calling functions that allow me to do that. So I'm going to have some logic that makes decisions based on the type of transport that we have. Let's look at the device class itself, because this is the important thing. So this is my class device. I say class, and then I give the name of the class. Remember, we use camel case, so you'll capitalize the first letter. And if it's a multi-word thing, as we will have in other situations, then you'll see camel case come into effect. Now this thing right here, remember, what did I call this? Put your mind back about, 5 minutes or something like that, or maybe you listened to it before breakfast or something. But this thing right here is called a constructor, and it's called a constructor because this is what gets called when we are going to construct an instance of the object. So somebody is doing what we were looking at here, where they say device parentheses, and then we're going to create it. And so when we're creating it, that's what's going to happen. Now, this is just like any other function for the most part in Python. So you're used to there being parameters. I could have had default values for these things. In fact, in another version, when I did this, I did have a default value. But these are the parameters that get passed in with one exception, and that is this magical thing right here. So every one of your member functions is going to start with this parameter self. So there will always be one. Now the caller does not pass in this self attribute. So when I call device, I just have name, hostname, device, transport. Here, even though it's kind of a unique thing, you see I have name, device type, hostname, transport. I don't have self. Self is something magically that Python uses in its implementation of object-orientedness under the covers. So all you have to remember and think about is the fact that self is referring to this instance of the object that has been created. Okay, those are not unnecessary words. That is important that you understand that. Self is referring to this instance of the object. So when you create this object right here, self is referring to its own data and functions. And if I were to go back to our picture, let's look at this picture right about here. Self is referring to this thing. When we are executing code for this object, then self refers to this object's data and also this object's code. And when I'm dealing with this object, then it's when I say self dot, it's referring to its own code. So just think of it in the real world type situation, because we are supposed to be reflecting reality. If it was a human being, then it would be referring to my own attributes or my own actions or activities that I can take. If it's a device, it's its own, that device's own data, and that's device's own methods. Okay, so that's what self is all about. So when we see this self, that's what it's referring to. You will make this mistake. You will say something like port equals 8181. I'm just doing something by hand here. And then your code won't work, and you'll wonder why when you called connect and you passed in port, it didn't work. The reason is you're not using this magical self pointer type thing called self. So you need to make sure that you are using self dot something, and you will make that mistake. I can guarantee you I make it not all the time, but I do fall victim to it some of the time. So just remember, when you're in an object and you want to refer to that object's data or to that object's function call, you need to specify self. Okay, so just get used to that. This is what we do. So constructor, we're not doing very much. You might say, well, why didn't you just do a connect when you construct it? And yeah, that might be a decent argument. I'd have to pass in information like credentials and port. I could have done that. It's just that sometimes you choose to do things one way and sometimes you choose to do them another, which brings up a point. You may run into people periodically who will tell you, well, yeah, you need to do it this way because in Python there is only one right way to do things and everything else is wrong. And my advice to you when you're dealing with these people is just nod your head and smile and then hope for them to go away so that you can get back to doing actual work. Now, I'm going to say something that is a little bit derogatory. I have found that some people who claim to be Pythonistas fall into this category where they end up being pedantic and arguing about every little thing. And my approach to these things is just to smile and nod my head and then go on my way and do the actual work, because people who are that way tend to be more concerned about the right way to do this and less concerned about actually getting something done. So there I go, off on a tangent again, but just so that you're aware of it. Now, there are good Pythonistas, obviously, and I see websites that say how to be a Pythonista and how, and that's great to become an expert in Python. I totally applaud that and I commend it. But when you become one, don't become a pedantic, bad Pythonista who just finds fault with everybody else's stuff and rewrites simple stuff simply because they would rather do that than actually get something done. All right, constructor. This is my constructor. This is what happens when somebody has called and this has completed. In other words, when I get to this line right here, that means that my object has been created and all of this code right here has been executed. That's what a constructor does. Okay, now the next thing that you see, let me point out. Remember we talked about data and we talked about code. Let me pull up this picture again. You have data and you have code. Well, let's look here. This is going to be my data. Now, Python is not statically typed and you don't declare all of your variables beforehand, but tools like PyCharm are getting to the point where they're recommending that you make sure to avoid confusion that you actually kind of in air quotes here, declare or at least do something with each one of the data pieces of data, each one of these variables, these member variables that you are going to be using later on. In fact, when I went through this and I think I hadn't put port in here and I set this and it said, PyCharm said, you haven't declared that. Do you want me to move this to the initialization routine? And so I said yes, and it moved it up there, which made no sense because port wasn't passed in. But that's to give you the idea that and I think this is a good practice, is to declare all of the data here. It will make it way easier to read later on. Could I have just done self.mac down here in a method and it would magically appear? Yes, that's true. At least that was true in the past. I don't know if there's been anything that has modified that, but just better to avoid that and declare all of your data right here. Now here, I'm not really doing anything. Could you do things in this? As I mentioned, I could have done a connect here. So yes, you can do whatever you want in here. In this situation, I'm just setting things up. Now we looked at our devices app and we saw that we actually called in with our device object. Our device object that just got created, remember, is this thing right here. This we stored it directly into this location with this key. Now I'm calling set port and set credentials, and you can see here I'm actually setting the port and setting the credentials. And remember again, you need to use self. So what this is doing is it's taking the username that got passed in and it's storing it in my local data. So now when I look at my object and I'm wondering what data is available in my object, that credential, that username is going to be present in this object. So whenever I do anything with this object, that piece of data is already there. I do not have to set it again. Okay, so that's what happens with the username and the password. Let's go look, with the username and password and with the port. Next, let's look at what happens when we actually do something, which would be connect. Okay, we've spent a whole lot of time at this point helping you to get a firm foundation in object-oriented programming and all this stuff, using self and having methods and having member data, etc. So the next thing's connect and get facts. I'm going to go through a little bit faster because I don't want to be spending too much time, but I will attempt to go over each of these adequately. And if you do have questions, please let me know. So when somebody calls connect, remember there's only one connect method that's going to get called in my application. When I come down here, I'm calling connect. I don't know if it's netmiko or Napalm or ncclient. I'm just calling connect. And so the way that I've implemented this, remember this is without inheritance, is I have this actual variable called transport, and that's going to tell me, is this Napalm, is it ncclient, or is it netmiko? And what I'm doing is I'm going to call into this function that I've created that will be either connect Napalm, connect ncclient, or connect netmiko, and it will return true if it succeeded. I don't have any error checking, so if it fails, it's actually going to barf, and that's not nice. In a real world situation, I'd want to trap that, but I'm trying to keep things simple here. What does connect Napalm pass? Well, here's what it passes. Remember, you need to specify self if you're referring to your object data. I'm passing in the host name, the username, the password, the port, and the device type. Device type was something that got sent in when we created this, and the device type actually is defined in one of my MISC types. It's actually, if I were to go to this and look down at it, I have device types, which this isn't completely pure because I have mixed these device types, which means something like NXOS_SSH. That's only relevant for Napalm, and Cisco NXOS, I can't remember, that may be ncclient, or maybe this one is ncclient. I can't really recall. They all have their own, so basically I'm kind of mixing things up there, but we're going to overlook that for the moment. I will be using it when I go down and call these. So I'm passing in hostname, username, password, port, and device type. Let's look at Napalm. What does Napalm do? At this point, bam, I'm in Connect Napalm. This code, if you've been going through this class, should look exactly the same as what you've seen before. Okay, I'm actually I took this code verbatim and I copied it and put it into this function, connect Napalm. So this is connecting to my Napalm device, and I'm not going to go through all the details. You understand at least a little bit about how Napalm works. While we're here, let's take a look. This is what's going to happen when we call netmiko. I'm going to do my netmiko thing. Just to clarify, I'm doing napalm.getNetworkDriver, which is actually going to return to me an object that I can then call open on. So actually the driver is what I'm going to use to create my object that is actually the device, and that is what I create, and then I can call open on that. Sorry for miscommunicating that. So get network driver gets me the appropriate driver based on the device type, and then I can get my device and pass in this information. It's the correct device. Now for netmiko, I do something different. I just am, and this should look sort of familiar to you. Look, it's one of those capitalized things. That means I'm creating an object instance, and I'm passing in to the constructor. Remember that word constructor? I'm passing in this information, which is kind of similar to the information that I just passed in, And then the result of that is I have a netmiko connection, and I'm going to return that. And for ncclient, when I go down here, ncclient, I'm going to use the ncclient manager, a thing that has been defined up here. I say from ncclient import manager, and I'm going to use manager.connect to create this connection object. And this connection object, when I create it, I'm passing in this information, and then I will be connected. I'm going to return NC connection. And when I look at my data here, what I'm ending up doing is I'm going to set my connection, whether I connect via Napalm. Remember, the thing that I passed back was a Napalm device. Whether it is NC client, that thing was a NC connection. In Connect netmiko, it was a netmiko connection. Remember, what I'm referring to is what got returned here, NC connection. Here we called it a Napalm device. Here we called it a netmiko connection. Within my device object, for all of these situations, I'm just calling it a connection. So it is my connection to the actual device. That is what connect is going to do, and then it's going to return true. Now the next thing that we'll look at is get facts, and this takes a little bit longer to describe. Okay, we've described connect, how as a user of this device object, all I need to do is call connect, and it goes out and does the netmiko or Napalm or NC client thing appropriately. I don't have to worry about that. The same is true down here for get facts. So I'm going to do a control B. This takes me into the get facts within my device class. Let's just remind ourselves where we are. We're within class device. We're going to one of the methods, and this method is called get facts. Now the code is pretty straightforward. I just do something depending on the transport type. And if it's Napalm, I call get facts Napalm, which I wrote, get facts ncclient, which I wrote, get facts netmiko, which I wrote, and those things I've imported right here, and they actually are in this file, this module right here. So let's go down here. Let's look at get facts Napalm. What do you suppose that looks like? Do you think it's complicated or simple? And if you answered simple, you're right, because actually, as it turns out, get facts is an actual method I can call in Napalm, all right? Remember, this is a Napalm connection. I passed in the connection, and I'm using the Napalm connection. And with Napalm, all I need to do is say get facts. And so here's my Napalm device. Get facts will get me FQDN, hostname, interface list, a bunch of dumb interfaces, model, OS version, serial number, uptime, and vendor. All of that comes by calling this function in Napalm. I don't have to do anything else, and I return that, and I can then from there just return that to the caller, and so my devices app gets that nice dictionary, and it prints it out just like we looked at over there. Now, if I am actually inside device and I'm not doing Napalm device, but I'm doing, let me do netmiko next, and I need to get the facts for netmiko. Well, this is going to be more complicated, so I'm going to go down into it. So here again, I'm in my facts Python module. It's just, remember, is this object-oriented? It's not. It is just Python code, right? This is just a function here. I'm calling this function called getFacts netmiko, and I passed in this thing called a connection. Now set your brains back to when we did netmiko. Remember what we do with netmiko? We send commands. So here I am sending the show hostname command, sending the show version command, sending the show license host ID, which is going to get me the serial number, and show system uptime. Those things are going to give me the actual output. Now the output is not going to be what I want it to look like. So I'm going to want my facts to end up looking a little bit nicer than they are, and consequently I may have to do something with them. So I can't just return this data. So I create my facts dictionary, and I'm going to return, as you can see, I do OS version, hostname, serial number, and uptime only. Now for some of these things like the hostname, I can just take the output and strip it, and I'm good to go. Now for the serial number actually comes back as a string which has a bunch of stuff at the beginning of it. And I don't want that part. I only want this part. And you'll notice in my in my comment I said don't do this. This is susceptible to the fact that somebody may move where the actual serial number is. Now that it's fixed data, the first 20 characters, you can see I'm skipping over the first 20 characters. Remember what this is called? This is called, with a string, starts with S-L-I-C, slicing. It's called slicing. I'm taking a slice, or you could call it a substring, but there's a substring command also. And so we're taking a slice of this particular string starting at character, the 20th location, and going till the end. And that actually gives us this. And I say don't do that. You'd probably want a regular expression. Now, if you want your regular expression, let's look at some of these other things. Now, show version output. Let's look at my get version from show. I had to write this, and this is what it is. I'm doing a regular expression here. So I'm looking for this actual show version output is about, I don't know, 30 or 40 lines of data. And I don't want that. I want the version to be just this thing you see over here on the right. So I'm looking for NXOS version, and I actually did this code in one of the lessons that we did. I cannot remember exactly where I did this. I think I did it in regular expressions, surprisingly enough, but maybe I can't remember. Anyway, I'm going to do the match to look for this particular version, and if I find it, then I'm going to take the data at group 1. I'm not going to go into regular expression details, and I'm going to return that. So there you see my regular expression. Now, the last thing that we have to do is I'm getting the show uptime output. Now, show uptime that has come back from get facts is just the number of seconds since it was rebooted. And so, unfortunately, when I do a show system, whatever it was, show uptime, what was my command? I forget. Show system uptime, that returns it to me in a textual, human-readable string of number of days and hours and minutes and seconds. So I need to split the output into all these lines, and then I go through every line of output and I look for system uptime because it gives many different types of uptime. And if there is uptime, then I split the line based on spaces, and then I get the days. And it turns out that my uptime parts in that line, the days are at the third location. That would be subscript 2 of this split from that line. 4, 6, and 8 give me days, hours, minutes, seconds, and then I just do this math to get the total number of seconds, and that's how I get this value right here. All right, so let's complete our discussion of getting the facts by looking at get facts ncclient, and you'll see that, well, I didn't do a whole lot here. In fact, if I was to go down here, you can see my facts are pretty sparse. I just got the serial number. That's because I don't know all of the wacky XML to get all the different pieces of data that I would want to get for facts. So I did one, and I decided any of you guys who know what you're doing and want to do the XML stuff, or maybe you even like it for some reason, then you could augment this code with whatever you want to get, like the host. I think I know how to get the host name. I could have gotten the running config and gotten the host name and maybe some other stuff, but I just didn't do that. Anyway, here we go. I'm getting the serial number, and you can look at ncclient to see this because I took this code from that. And here is where I get the actual serial number, and then that is all that the facts is just the XML. By the way, I did mention this in my netclient. I have a whole bunch of extraneous stuff in my netconf example when I do XML to dict parse, given the XML output that I get back, and you can look at that code and simplify it quite a bit. All I really needed to do was take the response.data.xml, which is an XML string, and then it will put it into a dictionary. And the dictionary has multiple levels. You can see here the first key is data, and then the value that I get is actually a dictionary, and the key that I want is system, and then that's actually a dictionary, and the key that I want in that dictionary is serial, and that gives me the serial number. And that matches this, which matches that, which matches this. And let's see, uptime, just for kicks, 2256, 2368. So you can see it's actually been rebooted recently. It tends to go down a lot. So uptime isn't very big, but you can see it's a different number because it took it a while to connect and then to get all of this data. So, whew. All right, that is my description of this device. Disconnect. If I was to look here, let me just go down and dive down into these. Disconnect for Napalm, I call connection.close. Disconnect for netmiko, I call connection.disconnect. And disconnect for ncclient is closed session. But you notice my lucky guy here, or gal, all they need to do is call disconnect. And I do all the ugly, heavy lifting depending on what it is. And I call either disconnect napalm. I could have actually put the code here because it's just a one-liner, but I preferred to do it in that way. So, like I said, that's object-oriented implementation of a device. I hope that makes sense. I do encourage you to ask me questions. If I've gone too fast, my apologies. I will, in our next time, I'll be talking about doing this a little bit different. You'll see I created an inheritance version of this that actually implements this thing that we're looking at, not here, but here, that implements that. But we didn't do that. We did this, and we saw how to create devices, etc. Thanks. Okay, so let's review what we talked about today. So today we were going to look at the actual code that implements this object-oriented stuff. First, we reviewed what it was all about. We looked at the device object that we're going to be creating today. And then we began to look at the code. And in the code, we looked first at the outer layer where we were actually pretty easy. All we have to do is a connect, get facts, and disconnect on our objects. So it makes our life very easy. We looked at constructing these objects and how it's pretty simple. We just pass in a bunch of parameters. We can also call methods to set data. And then once we've done that from the outside here, in this application, we can just do connect, get facts, etc. Within the object itself, we looked at a constructor. So how do you define how the thing is going to be built when it is created? And we looked at setting the member data. We looked at methods that actually set some more of the data. And then we looked at the stuff that actually did it, the rubber meets the road, where we actually go out and do stuff and connect either to Napalm or ncclient or netmiko, whichever is appropriate depending on the transport type. And then we looked at code that got the facts, which has to be different depending on whether it's Napalm, ncclient, or netmiko. That's the general idea. Is we have this simple abstract interface and we go out and do the dirty work as is appropriate depending on whether our connection type is going to be Napalm, ncclient, or netmiko. And then we return that, and we also looked at how you disconnect and that's different with every one of these. And how we store data, something like the connection, is extremely important. Once we have connected, then we don't really need to pass in anything to get facts. We just say, go get them, and it will go and get them for us because the information is stored inside this object that we've created. So that's what we talked about. Hopefully it makes sense, or hopefully you're a little bit further down the path of understanding object-oriented programming. As I say, feel free to give me any questions that you might have. Hopefully this will help you as you begin to get a little bit deeper into this software development thing. Thanks for listening.